So in this lesson, we're going to talk about dividing polynomials. So far, we've talked about adding, subtracting, and multiplying them, and some terminology with them, but dividing actually gives us a lot of information. So we're going to talk about things like factors and remainders, and we're going to learn two methods today, long division and synthetic division. So a quick reminder of long division back from elementary school, or maybe intermediate school for you all. If you remember this whole process, I'm just going to kind of talk you through it real quick. You take the 6, you ask yourself, how many times does that go into 8? It goes into 8 one time, so you put a 1 at the top. Then you multiply 6 times 1, which is 6, and then we subtract. And then we're going to bring down. We do the same thing again. So how many times does 6 go into 23? Well, 6 times 3, so the 3 is up here at the top, is 18. And then we subtract and bring down. So we get this repeating pattern for long division that you might want to write down, and that is to divide, multiply, subtract, and bring down. And then you end up back just repeating that process again. A reminder about this answer right here, this answer can be written as 83 is equal to 6 times 13 plus 5 left over. Or we can write that as 83 divided by 6 equals 13 plus 5 sixths. So that's 5 out of the 6 that we have left over. All right, so now what we're going to do is see how does this apply to more complex problems like polynomials. All right, so my question here says, let me divide p of x by this factor 2x plus 3. So I'm going to set that up for us. And what I want to show you in this particular example, notice that I've drawn some blanks here. I recognize that this goes all the way from x to the third down to the constant. But when we do long division, we need some placeholders. So I need to put in here a 0x squared and a 0x just to hold the place of those because they may become relevant as we start dividing. So just like with the other one, I'm going to divide. How many times does my first term, 2x, go into 8x to the third? And that is going to go in 4x squared times, right? If you divide that out. So now that we've divided, we're going to multiply. So I'm going to multiply this times this factor out here. That's going to give me 8x to the third plus 12x squared. All right, my next step says to subtract. So notice I need to subtract this whole thing. That is going to give me nothing in the beginning. That should cancel. And then negative 12x squared. And then my next step is going to be to bring down, and we're going to do this again, plus 0x. All right, so 2x into negative 12x squared, that's going to go negative 6x times. All right, so I divided. Now I'm going to multiply again. Negative 6x times 2x to the third. This is going to be negative 12x squared minus 18x. And again, I'm going to subtract. So if I subtract this, this becomes plus 12 plus 18, which will be subtract 18x. And then I'm going to bring down at the end out here my 27. And one more time, we're going to go back to the pattern again. I need to divide 2x into 18x here, so that's going to be plus 9. And when I multiply that out, that's going to give me 18x plus 27 and subtract, which will give me 0, which is good. All right, that's going to mean that my remainder here at the end is 0. And so one of the ways we can write our answer then is as a multiplication problem plus a remainder. So I can say that this p of x term, or the 8x to the third plus 27, equals 2x plus 3 times this solution I got for the division, 4x squared minus 6x plus 9. Ooh, running out of room. And then plus a remainder of 0 because there's 0 left over there. Now, long division isn't terrible, but it is a little hard to keep track of, and sometimes we have to do it. But there is actually a shortcut that we can use, or another method of division, rather, called synthetic division. And so let's talk about when we can use that and how it works. All right, so I'll make sure we label this synthetic division. Synthetic division, this says, is a method that can be used when we have a linear factor in the form x minus a. So notice in this factor, there can be no number in front of the x, and it just has to be linear, so it can't be x squared. So for instance, in this problem, x minus 3 is a factor that fits that requirement. So this is how synthetic division is going to work. First, we're going to take our coefficients from our original factor, and we're going to line them up on the top. And so I want you to notice what has happened here. This is x to the third, x squared. Just like with long division, if there is a term that is missing, we need to put a 0 as a placeholder, and then our constant at the end. Okay? Now we are going to deal with our factor. So if x minus 3 is the factor, this is kind of like when we did insides, opposite, outsides the same. If x minus 3 is the factor, then what I want to put in my box is what the solution would be if I solve that. So in this box over here, I'm going to put the value of 3. I'm not sure if you can even see that in the top. But the opposite of x minus 3 would be the value of 3. And synthetic is going to follow this pattern of adding and then multiplying. So it's kind of a shorter process than long division. And it's going to look a little bit like upside down division. Okay, so what we're going to do, we're going to add coming down. So notice in this first set, I don't have anything to add. So 2 plus nothing is just 2. And then I'm going to multiply coming up. So add and then multiply. So when I multiply, 2 times 3 is going to give me 6. That's going to go in this next spot. So I'm going to fill in, there's like all these spots that I'm about to fill in. Now I'm going to do that same step again. I'm going to add going down, so -1, and then multiply going up, -3. Add going down, -3. Multiply going up, -9. Add going down, -13. Now, you may want to pause the video or go back about a minute and re-watch that part so you make sure you understand where those numbers are coming from that I just got. All right, so this actually gives us a lot of information. And so what we need to do is talk about how do we interpret this answer and what actually information it gives us. All right, so this that has been given to us, notice when we divide something, if you think about it, you're breaking it into smaller amounts. So if I started with 2x to the third and I divided by a linear factor, this is now going to bump down 1 degree and it's going to be 2x squared minus 1x minus 3. And so you might ask yourself, well, what's this extra number out here? This last number is going to be your remainder. And so we can write this in a few different ways, relating it to the problem. We could say p of x, like in the last one, equals x minus 3, that's my factor, times 2x squared minus 1x minus 3, plus a remainder of -13. Or we can write it as p of x divided by x minus 3 equals 2x squared minus 1x minus 3. Similar to the original example in the very beginning, we can say this is minus 13 over what I divided by, and what I divided by was x minus 3. The format that we actually see most often, though, between these two is going to be this second format for writing your answer. So make sure that you have both of them written down, but be very familiar with that second one. All right, so let's talk a little bit more specifically about the remainder, because it's actually one of the most important parts of your answer. So what the remainder tells us, if you think about what a remainder is from elementary school, what that's going to tell you is that the factor that you're dividing into either does or does not divide into it evenly. So for instance, this first example, if I get a remainder of -13, that's going to tell me that x minus 3 is not a factor because it has things left over. It does not divide fully or wholly into the problem. On the other hand, if I get a remainder of 0, this means that x plus 2, so you might be wondering where I'm getting x plus 2. That's from the opposite of what was in this box right here. So -2, x plus 2. So that's going to mean that x plus 2 is a factor this time. Okay, we can also use this to interpret output values. So in this case, I have an input of 3 and an output of -13. Or I can use that to say that 3, negative 13 is a point. Or I can use that to say that f of 3 equals negative 13. The same thing can be said for this other value. If I do input output, I can interpret that to mean negative 2, 0, or I can interpret that to mean f of negative 2 equals 0. Notice that when things are a factor, they have this output of 0, which would mean that the point itself is a 0 on the x-axis. And formally, these two things are kind of referred to or help us explain something called the remainder theorem and the factor theorem. Okay, and I want to do one quick example about substitution just to help you understand where else this can be used other than just division. So in traditional substitution, if I was trying to solve this problem, I'm looking at years since 2015 and a population of 2023. That means I'm looking for when x, I guess x not t, when x is going to equal 8. So traditionally, we would plug that in to find p of 8. We would plug this in and do negative 8 to the third plus 6, 8 squared, plus 12 times 8, plus 325. And if you have a calculator, of course, that's going to be really easy. The problem is if you had to do this without a calculator, that would be some pretty big numbers that you would have to work through. So this process of synthetic substitution would have been really helpful, obviously, before calculators were an option, because it's going to make your numbers smaller. Let me show you what I mean. So if I know my x value is 8, then in my box, I'm going to put 8. And then I'm going to put my coefficients in the top row. So negative 1, 6, 12, and 325. And we're going to add going down and multiply going up. So that's going to give me negative 1 times 8 is negative 8. 6 times 8 is negative 2. Negative 2 times 8 is negative 16. 12 plus negative 16 is negative 4. Negative 4 times 8 is negative 32. And then when I add this, it looks like I'm going to get 293, which would tell me that in that year, the population would be 292. Oh, I'm sorry, 293. I said and wrote different things. That is a lot simpler of a process to do without a calculator because you can multiply all those numbers easier than having to do 8 to the third or 6 times 64 or 12 times 8 and having to work all of that out. So just know that that's an alternate option and one that I would encourage you to use more regularly.